Thank you, Lilia. Thank you very much for. Thank you all to be here and for the organization of this meetup. I'm standing where the X is, but still I have the light in my face, so probably I'm taller than you expected. So maybe if I move here, do you still see me in the picture? Okay, let's assume so. In Milan we are having meetups every month since basically more than 2 years, and we face the problem that sometimes the meetups are very advanced, like the last one we had Lalu, Rosbif, Shuntoku speaking about Lightning, and then before we had Paul Stork speaking about sidechain, and then Peter Todd, and then a lot of famous people of the space. They talk about very interesting topics, but the thing is that now there is like a new wave of interest in this topic, and some people comes there and they think like, okay, this is very interesting, but I really didn't understand anything about everything you say tonight. So the problem is how do you choose the topic of the meetup and the level of deepness of the topics. So my idea, since I don't know the kind of audience we have here, you are a lot of people actually, and I'm very happy to see that. And there was not even the ICO word inside the invitation, so this is actually genuine interest for Bitcoin. Since you are a lot of people, I will try to do some kind of hybrid between the classical meetup that we do with the technical stuff, new stuff, and the very basic 101 meetup for new people interested in this stuff. So I will try to do like this, but I want this to be very interactive, so please make noises, interrupt me, and shout and throw me things on the stage in order to adjust my speech as I go. My draft of idea, in order to proceed now, will be, we have 1 hour and a half, kind of. My idea will be to take 10 minutes just introducing myself and what we do in Milan and elsewhere with our initiative BHB Blockchainlab and related meetups. Then to take 25 minutes, and when I say 25, I really mean probably 50, but I will try to take 25 minutes in order to introduce Bitcoin from scratch, from start, using the most compact lesson about Bitcoin I was ever able to put together. And then other 25 minutes to talk about some news and some new challenges and something happening now in the space. So UASF, BIP 148, MUST, Schnorr, sidechains, and whatever. A very quick overview on the new exciting stuff or the new scary stuff happening, and then to have 30 minutes of Q&A. Of course, the problem with this kind of agenda is that in this part, probably some of you will be very bored, like, well, we know this stuff. So please, if you think that I'm going too slow about this, I will just do a face like this. I will see it and I will try to go faster, and we'll skip the part immediately. While in this part, the problem is that many of you that just maybe were introduced in the topic very recently, they will have absolutely no idea of what I'm talking about. Even here, please stop me. So let's try to do something that can be useful both for beginners and for experienced enthusiasts of the project, maybe since many years. So starting with me, I'm a former theoretical physicist, in theory, because I never really practiced theoretical physics. I worked in Accenture as a technology consultant for many years, and then I quit to do Bitcoin stuff, Bitcoin startups. The problem that I faced was that Bitcoin startups was very difficult, even more difficult than normal startups, because the monetization models, the revenue models, are not yet there in the Bitcoin space, except for very small, for very few exceptions like hardware or exchanges. For all the other, I mean, how do you monetize a Bitcoin wallet? This is exactly the same question of how do you monetize a web browser in 1995. It's not trivial, and it's something that is not easy to do. So after a while, I stopped, and in 2015, I built this BHB. We were called Blockchainlab at the beginning, but then every scam company, every scam consulting company started to build their own blockchain lab. And so in order to differentiate a little bit, we just took the first and the center and the last letter, and we built the BHB network, rebranding, and also taking away the blockchain word from our brand, because blockchain now sounds scammy. What is it? Basically, we have Bitcoin, so we have this big revolution of finance and technology and everything. And on one hand, we have incumbents. They have a lot of resources to waste on this topic. They really want to learn about Bitcoin. The CEO is calling every day the CTO, what are we doing about blockchain? And the poor guy, has to answer something. Usually, he will just blubber something absurd, but he has to answer. And they don't have any vertical knowledge. Indeed, I would say they have negative vertical knowledge. They know very few things about Bitcoin. They are almost all wrong. On the other, so a lot of money, negative knowledge. On the other hand, we have the Bitcoin experts. These are some of the smartest people on the planet right now. Bitcoin was able to select some of the most incredible brains on this planet. But these people is really without any kind of structure. They are scattered around the world. They are anti-establishment, anti-industry. They are driven basically by ideology, not really by business. By business principles. They don't want to speak with incumbents. They don't like incumbents. They will not work for incumbents. They are open source developers and also hackers, mostly, meaning in the broad sense. They are not the people implanting their ransomware everywhere. They're just people hacking stuff. And so they basically, and they don't have any monetization, any sound business model, any sound revenue model, because many of the most interesting projects are not intended to make money, but are intended to destroy the way you usually make money. Let's imagine you are doing a Bitcoin project. Basically, you're creating open source software that you will just release for free, so no intellectual property on that. You're creating a platform that everybody can join by definition, so no gatekeeping, because everybody can do everything with everybody. That's the nature of Bitcoin. So there is no strong lock-in of the users. They can enter and go as they want. So maybe, okay, I can sell users' data as Google and as Facebook, so that's my business model. No, because the great thing about Bitcoin is that you don't need user data, no credit card number, no sex, no age, no nothing. They can interact and pay each other without any data being involved. So basically, you have nothing, and to monetize this stuff is very difficult. So we build this. This is basically an arbitrage box. We take money from here. We use this money in order to help the best developers in this world to do their open source stuff. We give money directly or indirectly, like with resources, tools, spaces, travel, accommodation, integration, standardization, boost of interoperability. We help them to share their knowledge among each other, so their project gets better and they grow faster because they don't reinvent the wheel, they share the knowledge and they grow together, they reach critical mass. And we extract knowledge as a byproduct of that process, we package that, and we sell that to incumbents, like investment advisory, or proof of concepts, or reports or whatever. We sell information. This stuff started in Milan, but now we federated with Montreal and Johannesburg, and my intention is to create another center in Asia and another one in South America before the end of the year. So it will be a global network of super experts that will work freely on their open source stuff, just giving back not equity, not money, but information that we can sell to the incumbents. And which is this is a win-win, because these people is happy if some financial incumbent like a bank will start to use a real best practice instead of some scammy solution. If a bank start to provide Bitcoin custodianship, it's better if they do it following the best practice instead of following some stupid closed source, unsecure method. So it's a win-win for everybody. Okay, so this is what I do. Let's try to explain what Bitcoin is for somebody that never heard about this stuff in 25 minutes. Probably impossible, but let's see how it goes. So I try to explain this. How many of you don't have a very, let's say, complete idea? How many of you don't know what the hell Bitcoin is? Raise your hand. So one, be brave, don't be shy. I mean, it's natural. So, okay, let's try the double check. How many of you are really, I mean, they are convinced they know stuff about Bitcoin? They are Bitcoin experts. Raise your hand. Okay, so I will try to go faster here and to go slower in the other part. I used to explain what Bitcoin is to the 4 people that don't know it. I use basically 4 questions, the 4W, where, who, what, when. The where problem is very simple, everybody's talking about that, about distributed system. So the where problems start like this. Let's assume we have a financial ledger. So a ledger where there is there are transactions. Alice deposited $4 and so on, and Carl gave $2 to them, and this is the state of the account so far. And this is a financial ledger. So you have a village and you have an old man on top of the hill. He is a lawyer or a government guy or someone, and he keeps the ledger for you. So in order to change it, you go to his home, you go to Ted's home. Ted is the gatekeeper. Yeah, everybody trusts Ted. I mean, we all trust Ted. And Ted will keep the ledger for you. Everybody will be happy. This is how a bank works. This is how PayPal works. This is how, I mean, they're more complicated. They have a hierarchy of Teds, but basically this is the basic concept. This works fine, except in this situation where you have Ted becoming malicious and try to change or censor the financial ledger, so that maybe Alice funded WikiLeaks. Ted doesn't like WikiLeaks, and so Ted will try to destroy Alice's account, or to alter it, or to take money from him and put him in another place. Usually Ted is not very evil, because I mean, Ted is a businessman. He wants people to go to him to use his financial ledger. But the problem is that there is an external guy called Mallory. Mallory is typical the malicious actor in cryptography, and this can be like an employee, a rogue employee of Ted, or this can be a gangster organization, or a hacker attack, or a government, and they will force Mallory to censor the ledger, or to alter the ledger, or to manipulate the ledger somehow. So we have the problem that you cannot trust the ledger anymore because Mallory attacked it. There is a very trivial solution to that. Many people think that this is blockchain. So we take the ledger and we give a copy of the ledger to each and any one of the participants. Everybody is keeping his own copy of the ledger, and everybody is passing to each other an update of the ledger with the last change in the state. so the last transaction. This is not blockchain. This is just peer-to-peer open source software, and blockchain is something more advanced and more sophisticated. Many people from banks and insurance will tell you that this is blockchain. No, this is something that pre-existed blockchain by a few decades, and it's just decentralization and distribution of data among peers. So right now we don't have TED that can manipulate the ledger. We don't have even Mallory that can attack. We have at the first page of the book with instruction. Everybody has to follow the instruction closely. And out of the analogy, this is basically a peer-to-peer architecture using an open source code. For example, you all remember Napster, right? Some of you are young, but probably you remember Napster. We used that to download illegal music. No, I never did, but my cousin used Napster, and also your cousin probably, not anyone in this room, but your relatives did, and friends, not present here, did use Napster to download illegal music. It was all fine and good for them, unless Mallory came and just closed Napster, because Napster had a company, and you can always find and shut down a company, and Napster had a central server, and you can always shut down a central server. So when you go from Napster to BitTorrent, you solve that because you solve the where problem. Where is the server to shut down? Everywhere. You cannot shut it down because it's just clients connected in peer-to-peer way. So you have to shut down every single computer in the network. The where problem is easy to solve with decentralized open source software. But when we talk about the financial ledger, we also have a who problem. So who is enabled, who has the right to change the state of the financial ledger? Because if everybody has this right, basically everybody of you can change the state of the ledger and pass a copy which is I mean, tampered. This is not a problem with BitTorrent, because if I change a song and I pass you the wrong song, maybe, okay, it's a good prank, I will laugh, but then you don't lose money and I don't get money, so after a while I get tired to do that. And usually people do not tamper with other people's files a lot, and that doesn't have serious consequences. But if I tamper with a financial ledger, maybe I take my copy of the ledger, I take all the money from Alice, I put all the money of Alice in my account, and I give away this copy of the ledger. To solve this, this is not a problem if we have TED, because TED is the gatekeeper. It can control everything. You don't have this problem, and you don't need this solution if you have a central service. But if you don't have a central service, then you have to introduce this signature, basically. When Alice deposits his $4, she signs, and then every time that she will want to transfer her assets, she will have to sign again, and we will be able to check the signature, but we will not be able to reproduce the signature. Of course, you can think reproduce the signature is fairly easy, but I mean, for centuries, this is, I mean, yeah, centuries. This is how all the bureaucracy of the world has gone. Basically based on handmade signatures. Of course, in Bitcoin, we don't use handmade signatures. We use something more advanced, which is called digital signature. This is not blockchain. Many bank and insurance and consultancy guy will tell you, we are doing blockchain because we're using digital signature. Wrong, you're not doing blockchain. You're just doing digital signature. This stuff exists since 40 years. And in 1990, a guy named David Chaum created a financial system based on digital signature, like with Alice signing with digital signature, transferring to Bob. It was called eCash, and it worked fine. But this is how basically it works. For any one of you which is not familiar, you basically have a random private key of 256 bytes, and then you create from, well, you save it in your standard, you store it in your standard, then you create from these a public key which is cryptographically connected with the private key mathematically. Everybody can check that this signed something with this private key, so that this signed something compatible with this. Then you just create a cryptographical fingerprint of the public key, and this is the address, and this is the private key. So this is what we store in our wallet, and this is our public address where we receive the funds. So this is the who problem, solved, easy. eCash already solved it. You don't need a blockchain for this. But we have another problem. The problem is basically what? Because if everybody is allowed to create any kind of, to deposit any kind of asset, then everybody of us will just start to deposit everything with infinite inflation of assets. I mean, if there is no TED checking centrally who is actually issues something, I mean, if there is TED, we go to TED, we give gold to TED, and TED will write down, Alice gave gold to me. But if there is no anymore any TED, any centralized service, then everybody can write whatever the hell he wants on the ledger. So we need something that checks the problem of what are we transferring. In eCash, the what problem was solved in a centralized way, because in eCash there was a bank issuing a note, cryptographically signed, to Alice. Alice was transferring the note to Bob, and so forth. But we had the central point of failure. We had the bank. And so the government can go to the bank and ask the bank, please stop, and the bank will stop. So we need another solution. This solution is the proof of work. This is not blockchain. This was already attempted in 1998 by Wei Dai with a system called B-Money. So it's not an invention connected with blockchain at all. So what is this solution? Dear Alice, or dear everyone, if you really want to deposit a new asset on the financial ledger, you have to solve a very difficult puzzle that includes, which is very difficult to solve, but very easy to check, like, you know, a Sudoku. When you solve a Sudoku, you take a lot, or crosswords, you take a lot of time to solve it, but very few time to check that the solution is right. So you need that, and you need to include the address of the deposit and the signature inside inside the puzzle. So just to use this example, I used basically automatic how do you say that? When you shuffle the letters in a word or in a sentence. What? Yes, yeah, an automatic Scrabble, in order to find I take all the letters of this sentence. Alice deposited $4 signed by Alice. I put $4 in normal letters, and I scrambled it until I find a solution with existing words. So it took some work for me to do that. Of course, I used a computer, I used an internet program to do that, but I put some work in that. And so the most difficult is to puzzle to solve. The most guarantee we have that not everybody can just assign everything in the ledger. So what about we just change the rules in the first page of the book, and we say that everybody, in order to deposit something in the ledger, has to solve a very complex puzzle that has the address of the depositor as part of the question, so that you cannot reuse the same solution for another deposit. And we limit somehow the deposit, like you can just solve a puzzle every 10 minutes on average, and you can always you can only deposit 50 things, and then 25 after 4 years, and then 12 and 5, and so on. So you create a deflationary curve, or a not continuously inflationary curve, and basically you create, for the first time in history, you create scarcity on the digital world. So the digital world doesn't know scarcity traditionally, because everything in the digital world is information, and information is always easy to replicate and to inflate. If I give one information to you, you give one information to to her, and then we have 3 copies of the same information. But with this trick, we had, for the first time, scarcity. Probably I'm already getting longer than 25 minutes, so I will go faster. So we still have another problem, even after that magnificent invention of B-money. Why didn't B-money work in 1998? For a single reason. We still had a centralization problem, which was the when problem. So what if Alice signs that she's just depositing $4, she solves the puzzle, but then she gives $3 to Bob, but other $3 to Carl, but she only deposits $4. So if we do this in a smart way, we create 1 copy that we give to Bob with only the Bob transaction, and 1 copy we give to Carl with just the Carl transaction, then we have a double spending. If we have a centralized solution like TED, we don't have this problem, because TED will choose which transaction comes first and which transaction comes last. But if we don't have TED anymore, we need a way to solve the when problem. So this is the blockchain for the first time. Basically, we introduce a reference to the whole transitional history inside the solution to the what problem. So the puzzle that we solve will not just include the deposit, but will also include the solution of the previous page and all the transaction in the new page. This is basically I will need more time to make it more easy to understand, but this is basically the idea of the blockchain, born for the first time in 2008 with Bitcoin. So Bitcoin is just this, is a shared ledger with digital signature, ACDSA so far, we're going to change it, with proof of work, like B-money, and with a blockchain. The only thing that blockchain does is just to avoid double spending, because it includes inside the proof of work not just the address of the depositor, but also a commitment to the history, to the single consistent history of the asset. That's the blockchain. So, Bitcoin 101 finished. Probably I took a little bit more than expected. How long did it take? I don't know. Oh, okay, let's go on. So, now that everybody here understands Bitcoin perfectly, and we are all on the same page, so the 4 people that raised the hand now, we are all on the same page. You are a Bitcoin expert. Now we go on with some interesting, I think, topics that stuff that is happening right now. The first topic that usually people asks about during the meetups is this giant fork war that we are facing so far. And the challenge that I like to refer this topic to is the problem of the independence of Bitcoin. Then I will analyze a little bit the problem of the scalability of Bitcoin, the privacy of Bitcoin, and the expressivity of Bitcoin. But I do not put the fork war inside of this paragraph. I put the fork war inside this paragraph. So, disclosure. In this part of my talk, and in this part, and in this part, I will be, not very controversial, probably. I will be mostly objective. While in this part, I will show very strong opinion about something which is strongly debated so far. So I could just pretend that I don't have a strong opinion, like, I don't know, you go to, you know that there are guys that think that the earth is flat, right? You can go to the debate, and you know that there is people that is convinced that the earth is flat, or that there are chemtrails in the space caused by reptilians, and you can pretend that you give some sort of legitimacy to these theories, but you don't. So I will not do like this. I will just put on a disclaimer. The next part of my talk will be controversial. I think that what I'm going to say is factually true, is not subjective, is not my opinion. I think these are facts, but there is people that strongly disagree with me about this. So, basically, what is all this thing about UASF, BIP 148? Who of you is, has heard something about the 1st of August, WASP and BIP? Who has heard something about this debate? No, not a lot of people. So I try to very, not impartially, but very, with a strong view, I will try to give you my view, which I think is correct, of the debate so far. Basically, almost after the release of Bitcoin, Satoshi Nakamoto included a fixed dimension for the page of the book. So you remember the pages with all the transactions. You can do infinite pages that can take inside every kind of transaction, but Satoshi Nakamoto chose a limit for that. It was intended as a spam defense at the beginning, but that it turns out to be very important also for other reasons. First of all, it can incentivize fees, the fee mechanism. Second, it prevents selfish mining attack, or it doesn't prevent it, but it makes it more difficult, and it can make more difficult network partitions. So it has several. This limit was a very good idea, but there was the lead maintainer of Bitcoin at that time, Gavin Anderson. He wanted to change this limit very fast and in a very strong way, like make it 10 times larger or something like that. The process of Bitcoin is such that you cannot change Bitcoin if you don't have everybody agreeing to it, because you have a shared code, a shared peer-to-peer open source protocol, and if you don't have the consensus of everybody, you basically cannot change it. I mean, go on, change it, but you will be just forked off the network. It's like internet. If you don't like TCP/IP and you want to change it, go on, change it, but your computer will not connect to the internet. You have to launch a new internet and to ask people to join your internet instead of the internet. This is true even if your solution is better than the existing internet. Like IPv6 is better than IPv4, but I mean, internet so far is IPv4, and they are trying since more than 10 years probably to upgrade, maybe even more, but the network is slow to upgrade because, I mean, the existing network has a strong inertia. So the process of Bitcoin, which is based on complete consensus, didn't reach consensus about removing or enlarging this limit. This problem, this fight, this debate started about the block size, but it's not really about the block size. It is about Bitcoin governance model, which is a completely separate issue. It could have happened for other kind of topics easily. It's just a contingency that happened with the block size. So Gavin Anderson stopped to look for consensus inside the development community, and he published a blog post that said, this is my solution. I will not push it through a pull request in GitHub because people is not listening to me, but this is what we have to do, and this is what I think we have to do. So people started to debate the stuff on Gavin Anderson blog instead of in the developer mailing list, and basically this created a first fraction in the governance model of Bitcoin. Then we had another guy which was already, even if it was not public, working for R3Sev, which is a company that sells private blockchain, which are not blockchain, but I mean, when they go to a blockchain conference, they say that they are doing blockchain, but then when you point out they're not doing blockchain, they say that they're not doing blockchain. Basically, they say they sell databases. And this company employee, Mike Hearn, started to create an alternative version of Bitcoin called Bitcoin XT, trying to promote that. The network didn't accept this upgrade, and this upgrade failed. Then there was another attempt, Bitcoin Classic, that was a little bit less extreme. Bitcoin XT was like 8 times the limit immediately, and double limit every 2 years, very aggressive. Bitcoin Classic was more simple, like just double the limit now, and then we stop. This failed as well. Then it was the segregated witness idea. So segregated witness is a very nice idea. Basically, in the page of the book, you can have the signature of the people inside the transaction, where the ID of the transaction includes the signature, or you can have it outside, where the ID of the transaction doesn't include the signature, and the signature just signs the transaction with the ID, which is a problem that many of you will probably understand. The ones that who doesn't understand, just trust me and don't verify. Basically, if you take it out, you have some advantages. You don't have external transaction malleability, you don't have quadratic SIG-hash problem, you can validate faster, you can sign faster, you can throw away some part of the blockchain after you verified it, you can prune your blockchain better, you can, well, a lot of stuff. And also, Segwit allows you to upgrade the script model of Bitcoin in a better way, allows you to basically sign the amount, which is very useful for hardware wallet. So a lot of nice feature. But then there is what, in my opinion, was a problem. The Bitcoin developers tried to frame this solution, which was a very good technical patch, as a solution for scalability, trying to please the community that wanted more scalability. What is the scalability problem? Scalability problem is that if your page is limited to 1 megabyte, you can just host so many transactions, and then you don't have space anymore. And so if you have more users than the space, what happens? The same thing that happens when you have a restaurant which is very crowded. They have to select the clients, and usually they select the clients that arrive first or that pay more, or both things. And so basically Bitcoin right now doesn't scale in this way, because we have like 3 transactions per second, maybe 7 theoretically transactions per second, which is not even, I mean, the fidelity points of a supermarket. Is not a financial network, 3 transactions per second. So the guys in Bitcoin said, Segwit will be used for scalability because when we deliver it, we will give a discount of the on the signature part of the transaction, so that you can put more transaction in the block, up to 4 times more transaction. So you wanted 2 megabytes, we are giving you 4 megabytes in theory, when everybody upgrades to the new transaction format. So everybody will be happy, right? Wrong. Everybody wasn't happy, because this was never about block size. This was about control on Bitcoin development. This was about showing that you have control or the other guy has control. This was basically a political debate and not a debate about scalability. Indeed, there was this solution providing up to 4 times 4 times more transaction eventually, and they deployed it with something called BIP, Bitcoin Improvement Proposal 009, which says like this. Previously, many soft forks. So, and a hard fork is when you violate the rules of the protocol, when the protocol is following some rules, and you suddenly say, no, this rule is no more, is not valid anymore, and I can include transaction that will violate these rules. So I'm enlarging the rule set. I'm including transactions that were invalid before. So as you can understand, with a hard fork, I can do a lot of stuff. Basically, I can change the rules completely. I can hard fork in a way that people can that Bob can take Alice's money. I can hard fork in a way that miners will will get 50 Bitcoin instead of 12.5 every 10 minutes now. I can hard fork in an infinite way, number of ways. While a soft fork is different. The soft fork says the rules of Bitcoin that applied yesterday still apply. Nobody will be able to violate the rules, but we will just enforce a new set of rules on top of that. So basically, you are vegan, you don't eat meat or fish, and on top of that, you are also becoming carb-free. So you basically just drink water now, or probably eat vegetables. So this is a soft fork. You already have a set of rules, you keep that set of rules, and you add a new set of rules. While a hard fork is, you were vegan, but now, I mean, this steak is very tasty, and please eat it. Yes. So this is a hard fork. So the BIP009 is a Bitcoin improvement proposal that says that for every fork, even a soft fork, we have to wait until a majority of the miners will signal that they are ready for this improvement of this upgrade, ready to this upgrade. Usually, soft forks in Bitcoin were almost never delivered with this mechanism. Soft forks were delivered just normally, like since it's just a new rule, just a small part of. While for an hard fork, everybody must agree. Everybody has to agree to the change of the rule in order to not fork the network, not split the network. For a soft fork, just a minority can agree. They will follow the old rule plus the new rules, and all the other guys will just follow the old rules. So you don't need global consensus for a soft fork. You can just have part of the network agreeing to the new rules. So that's why usually soft forks were never deployed using this mechanism that requires 95% of the last 1,000 blocks to signal readiness for this upgrade. While for this specific case, since SegWit was already very controversial, there was a lot of fights, there were people telling that SegWit was a malware, SegWit was a conspiracy, SegWit was not technical people, basically, people outside the technical development. But since there was a lot of controversy, Bitcoin developers said, okay, we will wait until there is 95% of block signaling that the miners are ready for the upgrade, and only then we will lock in the upgrade. What happened is that miners started to, then there was another hard fork attempt that failed again after these two. But in the meantime, the miner decided that they will use this signaling mechanism as a political bargain method, like agreement, let's say, compromise method. So I will signal that I'm ready for your soft fork upgrade, which is something that will affect only you, but I will signal that only if you give me something else, which is basically a hard fork, which I proposed. So they started to use this signaling mechanism as a political compromise catch. This didn't work because nobody is giving them, I mean, the hard fork in exchange of for the activation of SegWit, and basically what it started to get consensus was the idea. That's what my hat is about. So this wonderful hat is made by Samson Mo, former CEO in BTC China, now strategist in Blockstream, and you know that there is the United States Air Force hats, USAF. Which is made like this, and this is a user-activated soft fork version of that. User-activated soft fork means that you don't wait anymore for the miners to signal that they are ready for the new upgrade. Since it's just a soft fork, you just activate it on your own. If the miners agree, good for them. If they don't, their block will be probably orphaned by the network. So this is a UASF. This is not really something new. It was used before, like for the delivery of P2SH. It was basically like this, just an activation date. But they tried to do BIP009. It failed so far, and so they're doing this. Basically, in my view, which is very controversial, and maybe you disagree with that, but I don't care because I'm not on the stage and I have the mic. Or maybe we'll disagree later in the questions. So in my view, what happened is that miner that wanted to pass the narrative that the hashing power is what decides the rules of Bitcoin, which is not. If you remember the examples before, the rules of Bitcoin are not decided by the solution to the proof of work. The rules of Bitcoin are fixed, and then you just avoid the double spending problem with the hashing power. So your Bitcoin client, your Bitcoin wallet, your Bitcoin node doesn't follow the chain with more hashing power. It just follows the valid chain with most hashing power. So if you have a chain with hashing power X, and then you have another chain with hashing power Y, which is way higher than X, but the second chain has an invalid signature, your wallet, your node, will reject it. If it has an inflation which is not going accordingly to the schedule, so it's not following the halvings process, it will reject it. So you are not following the longer chain. You are following the longer valid chain. And the validity rules are not decided by miners. The validity rules are decided by your node, and so by us. And so they're basically almost impossible to change, in a real decentralized network. The only change that are possible are changes that are really uncontroversial and absolutely just like patches for bug fixing and something like that. So basically what happened is that they understood that UASF could be actually a way to destroy this attempt to get a compromise. And so they said, okay, we will signal SegWit. In practice, what will happen for the ones of you that are following in depth this debate, on July 21, they will start to signal bit 4, not BIP, not BIP, not blockchain incredible party, but BIT, so the bit of the header of the block, the bit 4, and if for 2 days more than 80% of the miner of the blocks will signal bit 4, then everybody following BIP 91, I know that you feel a little bit lost right now, but it's normal, they will start to signal bit 1. And if they signal bit 1, after other 2 days, they will start to orphan every block that is not signaling bit 1 because of that. So this is basically a miner activated soft fork, a MASF, a MASF, and it basically will activate before UASF. So they will be able to say that they won because they avoided UASF in exchange of a hard fork that will take place in October, end of October or beginning of November. And my take on this question is that it will never happen. The hard fork in October will happen just as much as this one, or this one, or this one. And this is this one. I mean, a miner is not stupid. It doesn't want to lose money. So it will run a software which is Bitcoin Core adapted for their own purposes, so patched, customized. They will not run a code that 4 guys from some internet service developed just 2 days before in a closed source way. They will never do that. They will signal in the blocks like they are following this software, like they were. I don't know how many of you remember when Bitcoin Unlimited, the several times Bitcoin Unlimited crashed. One time was the Acer Zero. I had the t-shirt yesterday, the Acer Zero bug. So Bitcoin Unlimited crashed 3 times, almost completely, because I mean, it was not developed by real Bitcoin developers. And so it crashed completely, every node went down, but the miners signaling Bitcoin Unlimited weren't down. Why? Because they weren't running Bitcoin Unlimited software. They were running normal Bitcoin software, just modified in order to signal that they are running the other implementation. This is what is happening now, and so I might think there will be no hard fork in October. it will, probably in September, it will happen something like a new debate, a new fight, a new news, some new agreement that will just delay this stuff for a while. So this is the end of my controversial part. In the Q&A, maybe you will want to challenge this view, and I will be more than open to disagree with you. But now we will be a little bit fast because I think we are out of time, right? 20 minutes also for the questions? Oh. Okay, so very, very quick. Scalability of Bitcoin. I just name drop something. Join market. Join market is not a scalability solution, is mainly a privacy solution. Basically, you create your transaction, and instead of broadcasting it on the blockchain, you wait for other people to join the same transaction with their transactions, and you, in a trustless way, you basically create a unique transaction that keeps every transaction inside. Basically, this can also be a scalability improvement. Then you have a segregated witness. This is, that can give all the advantages that we talked about, so SIGOPS improvement, quadratic problem, more space, and so on. Then you have a lot of general optimization, but I don't have the time to talk about them. Then you have the Lightning Network. I hope everybody of you knows something about the Lightning Network. It's a very neat idea. The idea is that we don't need the blockchain to do everything. We just need the blockchain to do settlement if something goes wrong, but we can use an off-chain transaction. I mean, when we guys do a contract, we don't go in the court to ask the judge if our contract is right and to sign our contract. We don't do that. We just do the contract and we go to trial only if there is a breach of contract. That's the same basically, but with a perfect and incorruptible judge, which is the blockchain itself. So basically we create channels, we exchange off-chain update in these channels. We have a root mechanism that goes to pay everyone, and we go on chain only if somebody tries to do some nasty stuff. And who is trying to do nasty stuff will lose the money, and who is honest will keep the money. Trustlessly, mostly. So then we have SSSS, which is basically Schnorr signature scriptless script. Schnorr signature scriptless script is a new way to do scripts in Bitcoin transaction without using the script opcodes, but using a new form of digital signature. I say that digital signature in Bitcoin is CDSA, but there is another kind of digital signature, Schnorr, that was not used in Bitcoin because it was a closed source. It was patented up to a few years before Satoshi Nakamoto published the paper, and this will allow to do like multi-sig 90 out of 100. Right now you cannot do that, but with this stuff you can do that. Then there is MAST, which is Merkle abstract syntactic trees. I don't have the time to explain it, but it's very cool. Then there is possible the study about the first Bitcoin hard fork. The study is called SpoonNet. There is a lot of developers that are thinking what are the upgrade to Bitcoin that cannot be done with the soft fork. The idea is if we really need to do an hard fork, so if we really need to change the rules of Bitcoin, what should we do with that? Maybe just once in the history of Bitcoin, but what can we put inside that? And so there is a lot of study to try to do an hard fork, but maybe it will never happen. We will know if Bitcoin will ever hard fork. It's possible that it will never do that. So we have sidechains. Sidechains are not a scalability solution per se. I don't have the time to explain why, but sidechains are not a scalability solution, but sidechains are a solution in order to experiment different scalability solutions in a meaningful way. So you can do a sidechain that has, for example, big blocks or fast blocks. You can do a sidechain like Mimblewimble where the blockchain actually shrinks over the time. You can do something completely different from a blockchain like a Tangle, like IOTA or something like that, or Dogecoin or whatever. So this is a way to experiment new scalability solution directly in production without doing hard forks or without messing up with Bitcoin. Third challenge, privacy of Bitcoin. Again, joint market is also a privacy feature. Again, Lightning Network is also a privacy feature because an external player will not see every one of our transactions. They will just see the opening of the channel and the closing of the channel. But everything in between, with all the routing, they will not be able to see it. So great privacy, great confidentiality. Also, SSSS and MAST are very good for privacy because in the transaction you will not put multi-sig. I mean, every transaction, after these two stuff are activated, every transaction will just look like one single signature and a hash of the remaining part of the tree. And that's all. Nobody will be able to look inside the script, the other parts of the other branches of the script, or inside the other signatures. Great privacy. Also, sidechains can be used in order to create a sidechain of Bitcoin with confidential assets like liquid or elements, or sidechain Mimblewimble, or a sidechain that uses ring signatures, arranged proof like Monero, or zero knowledge proof like Zcash. Zcash is an altcoin, is a scam coin, of course, that, like every altcoin, that uses something which is called ZK snarks, which is a kind of general purpose zero knowledge proof in order to boost privacy. ZK snarks are already very old. They were put into Zcash, but then ZK stars came out, which don't need a trusted setup, and now people is experimenting with the ZK Boo, which even better. Boolean, okay, I don't have time to do this. So, expressivity of Bitcoin. What about super complex smart contract? I mean, yes, Bitcoin is fine, but in Ethereum, I can do a smart contract where I check the temperature of the water in Odessa and I link it to the stock market prices. I mean, everybody needs that, right? There are so many use cases for that, but we cannot do that on Bitcoin. Wrong, we can. The most interesting, in my opinion, way to do that is using trusted hardware. For example, Ledger, the company which is producing the Bitcoin hardware, is doing bolos that are anti-tamper hardware solution that will basically do. I don't have time to explain this. Again, okay, maybe if you ask a question about bolos, I will spend some Q&A time to explain bolos. Okay, I do that. Also because this is the last slide, so I can do that. Basically, the idea is this one. An hardware producer, Alice, creates an hardware. It doesn't put any software in it, any firmware. It just says, it just guarantees that the hardware will print in the output the fingerprint of every kind of software running in the hardware. So I create this empty box and I tell you, this box, if you open it, you break it. If you try to open it, you destroy it. There is a private key inside, or better, you can put a private key inside and you can put a firmware inside. The machine will sign with the private key that you put inside and will leave a cryptographical fingerprint of the software you will put inside. I, producer, I don't know what you're putting there. I don't know your signature. I don't know your private key. I don't know your firmware. I just give you the guarantee, trust me, then the hardware will do like this. Then another party, which is Bob, takes the machine, puts some firmware in it, for example, an open source smart contract connected the temperature in the seaside of Odessa to the stock market price. And then this firmware will be executed leaving a fingerprint. So now you create a Bitcoin address that can be spent only if you have the signature of the hardware and the fingerprint of the software you want to run in the hardware. So in this way, Alice cannot mess up with the software. So Alice cannot ex post modify the software, and Bob cannot change the software afterwards because the fingerprint will not be valid anymore, and so the address will not release the Bitcoin, and then Alice can trade with a smart contract. There is also the possibility to do nice stuff with covenants. but I don't have the time to explain that. So, it was a difficult experiment for me, so sorry if it was too much boring for someone in some parts, or too much strange for somebody else in another part. I hope that maybe in this last Q&A session, you will be able to tell me it was boring or I didn't understand anything.